Okay, so we have reached section 6.3 if you're following along in the textbook. And what I would like to do is set up a picture for you. I'd like to set up the line L and some point P that's not on L. And we're going to drop a perpendicular, and that perpendicular is going to have the foot A. And we're going to choose a point B in either half plane bounded by AP. It really doesn't matter where B is. So we're in hyperbolic geometry, which means there are multiple parallels to L through P. So, and if you're drawing right now, I'm going to draw some things that I'm going to erase. This line we know is parallel to L because it comes from the double perpendicular construction. We also know that there are some other lines that will be parallel to L and that will come that will come below the blue line, so to speak. We also know that there are some lines that will absolutely intersect line L coming through P. And we know that because we can take any point on line L and connect it to P, and that line will intersect line L. So the question for us today is, when do the greens turn into the reds? That's the question. When do the greens, the lines that intersect line L, turn into the reds, the lines that pass through P and are parallel to L? Where does that happen? How does that happen? Because there are clearly some parallels and there are clearly not some parallels in our hyperbolic geometry. So let's set up some vocabulary to talk about this. We're going to let the set K be the set of all R such that ray PDR intersect ray AB is not the empty set. Well, what is that? Well, that is this ray. This is point D sub R, where R is the measure of this angle. So if we draw the ray at a 42-degree angle to segment PA, if the measure of angle AP D sub 42 is 42, and if this ray hits line L, then 42 is in the set K. And if we draw ray PDR such that the measure of angle APDR is 68 degrees, and that turns out not to hit line L, then the number 68 is not in the set K. The set K, this is called the intersecting set. The intersecting set for P and line AB. Couple of things. K is a subset of the set of numbers from 0 to 90. Clearly, 90 is not going to be in this set. And K is of the form 0 to R sub 0, where R sub 0 is called the critical number. The critical number for P and line AB. Why? R sub 0 is the place where the greens become reds. And in fact, there's a theorem we should play with. If R is an element of the intersecting set, then two things are true. S is in the intersecting set for all S between 0 and R, and there exists a T in the intersecting set such that T is greater than R. Gonna draw, gonna erase. We're gonna pretend that R is in the set. If R is in the intersecting set, then the ray PD sub R intersects line L. Well, then clearly by betweenness, every angle less than R, every angle whose measure is less than R, is going to hit at some point between A and this point here. And if we choose a point on the other side of this purple dot as A, and we draw that ray, the ray from P to that point, then that will obviously be in the intersecting set. So there is a number T that's bigger than R that's in the intersecting set. If this is true, and we believe that it is, then R sub 0 is the least upper bound for the set K. It's not in the set, but it's the smallest number that's not in the set. Okay? That's a big deal. That's a big deal. So this is a diagram you should be familiar with. This is vocabulary you should be familiar with. I'm going to talk about angle of parallelism in the next video. You need that.